find the moment of inertia in a situation where something is being rotated around a center of rotation or an axis of rotation that is not its center of mass. Eventually, we will try to rotate this long, slender rod about some middle point here. And the reason is, I want to start here because you guys are familiar with the moments of inertia for a long, slender rod rotated about its center of mass, but you also have derived an expression for the moment of inertia around an end axis. And we saw that the moment of inertia increased. We did that maybe about a week ago. I would like to do a shortcut with that today using the parallel axis theorem, and then we'll move the axis of rotation to a different place. It is important to notice that these two axes of rotation have to be parallel with each other in order for this to work. So what it says then is the moment of inertia around an end axis, in this case P, which is parallel to the original axis of rotation that went through its center of mass, is equal to the moment of inertia of the original bar rotated about its center of mass plus an additional amount. And the additional amount is simply the mass of the object times the separating distance squared. The separating distance d specifically is the distance between the two parallel axes. So, if I wanted to find the moment of inertia about point P, it'd be the moment of inertia around the center of mass, which we know to be 1/12 ml squared. In this case, I'm going to now add to it the mass of the rod plus the separating distance, but I have to remember to square it. The separating distance is L over 2, and I have to remember to square it. This is the additional moment of inertia that I'm adding to the system because of its axis of rotation being skewed off to the side like this. You can see that this becomes 1/12 ml squared plus ml squared over 4, or 1/4 ml squared. I'm then now going to find a common denominator of 12. This gives me 1/12 ml squared plus 3/12 ml squared, which gives me 4/12 or 1/3 ml squared. That should look familiar to you from the moment of inertia that we derived around the end axis using calculus methods. But now you can see that there are other ways to do that using the parallel axis theorem. Are there questions about that? A great example of using the parallel axis theorem in a situation where it'd be much harder to use more traditional calculus methods was what if we chose a different axis of rotation. Let's call it point O. And we'll say that point O is L over 6 from the left end. I'd like you guys to spend a few minutes deriving an expression for the moment of inertia around this parallel axis through line O. Go.